Alright, how's it going? This is Sam Welker with ThinkParticle.com, and we are going to make a very enthusiastic thinking particle tutorial today. And what we're going to be doing is creating this effect right here. As soon as I find it. Here it is. So it works a lot better with the Daft Punk Tron Legacy album playing in the background as you watch it, but it comes across pretty well as is. And this, would not be complete without a lens flare. So there you go. We're going to be making these white little particles shoot across, and as they shoot across, they're going to draw this blue line, and they're going to move only in one axis, either in the positive or negative direction. And we're going to show you how to create that, and it's going to work inside of these inside of this text object right here. So it's a revealing way to create 3D text. Very revealing. So we're going to start out by showing you the scene, and I'm going to tell you first off, this is a really cool effect done strictly in Cinema 4D. It's going to be really, really neat. You don't need any third-party tools. I do use the TP toolkit from thinkparticle.com to help with the workflow. And what it will do in this case is allow me to emit particles from other particles. But other than that, there's nothing in here that there's nothing in here that won't be done just natively in Cinema 4D. So let's go ahead and watch as it draws these other particles, or all these particles and these lines, and as you can see, they move in a lot of different directions. The particles are moving left and right, up and down, forward and back, and they draw these short lines. And in the video you saw, you actually noticed that as they draw, they emit other particles and get more complicated lines. And as those particles draw, you're going to get even more complicated lines, and you get really cool designs like this. Alright, and as these particles draw these really cool lines, you get these really complicated shapes in graphs. So imagine you get some graph paper, and you can go and you trace lines, and you're going to get some 3D graph paper, which is even cooler, and you're going to just keep drawing lines and lines and lines, and it takes hours and hours and hours, but with thinking particles you can do it really quickly, and you can get really cool looks like this, which is a little dark right now. But we can fix that. Oops, what did I do? There we go. This guy right here, we'll fix it if we can grab it. Having a little fun with my Wacom tablet on my Windows machine. So anyways, that is the lines that are being drawn. So I'm going to show you today how to draw lines like that, and I will show you the rest of the setup. So first off, this is a very basic particle setup. Well, it's not super basic, but it's not incredibly advanced. We have a P matter waves node which is emitting from 3D text, and as it emits, it's going to move in a defined direction. Now, as you'll see right here, there's no speed on it, so you might wonder, well, how is it moving? Well, we have a P set data node that uses a velocity defined by these random nodes right here, some multipliers, a little code, and a utility node that will allow us to take this code and turn it into a vector. Makes it a lot easier. So we emit these particles, and they go initially into the initial particle group. And as they're in the set data node, we're going to say, hey, you're a particle in this group. We want your velocity to be this. And a velocity is going to come out if we go and grab a result node and come out in, if I grab the vector version of the result node, you'll actually see it will come out in one of these right here. It's going to come out in the y-axis, the x-axis, or the z-axis in a random number. Alright, so the basic setup is just, we have these particles. These particles go into this P group node, and it says, this is your group. Be an initial particle. Anything that's an initial particle is going to inherit the velocity in the frame that it is birthed. So as a particle begins, an orange particle begins, maybe if we turn it to flakes you'll see better, any of the orange particles as they begin their life, this math right here is going to define their velocity, the speed, the direction they go, and when and why that is done. So it starts with the speed. We have a random generator that goes anywhere between -1 and +1 based on time with a random seed of 3, 4, 5, 6. We multiply that by 10, which gives us anywhere a value between -10 and +1. And then we multiply that by 20, which is the factor of what speed we're actually going to be sending into our script right here. Now, before we get into the script, let's go back to this other random node. This random node, which is positive only, will define which axis it's going to shoot off in. So it's going to be anywhere between x, y, or z. And you will define that by having a particle shoot out, I messed that up. Anywhere between 0 and 1, you're going to have generated with this node, and if you multiply it by 10, it goes between 0 and 10. As that happens, you're going to have the ability to have particles in this code right here defined with this speed and in the time-based direction. So anywhere between any random number generated, under 3.3 is going to inherit in the x-axis. Any number between 3.3 and 6.6 is going to be in the y-axis. Any number above 6.6 is going to be in the z-axis. You're going to then have these axes shoot into the reals to vector node and then shoot that into velocity. And what that does is it takes this number, which is 0, 0 speed or 0 speed 0 or speed 0, 0, and that is the particle. It will inherit that and keep that until it dies. And then we say, we have to adapt it, we have to convert it from these numbers into something that can work with it. We need to turn it into a vector. And we did the same thing twice more. We're birthing particles off of particles. And these same things, just with a bunch of extra result nodes, allow us to do that. Now, as a particle's flying around, as you can see right here, they're dying at the edge of something. And as you've seen already, it's 3D text. And we've done that with the PPAS node, and any particle that hits this triggers an event, and it will die. And we used some geometry right here that we basically took the same geometry and emitted it 5 times over. And what that allows us to do is have the particles birth, and if it doesn't actually hit the geometry, which actually a good example is this pink one right here, it did go through the first layer, and if we move forward in time, it dies because it hit the second layer. And as these particles hit the second or third layers, it just gives us a security option that a particle's not going to escape from this deflector right here nearly as easily if it just went inside of a simple one piece of geometry. Instead of 1, we have the same geometry multiplied 5 times over, and it's scaled like such. I'll give you a visual example. So if we make it editable and go into this mode, the polygon mode, we hit D after, we hit Control A to select everything. We hit D and allow ourselves to turn off preserve groups and scale it out. And we did that, and we then would go ahead and move it out even more, and then we'd move it out even more, and then as we're duplicating these and getting more space in between them, we have all these particles, or all these ways that the particles just aren't going to die, and then we connect it into one object, and that just gives us this option right here, to have just multiple levels of security so that the particles are not going to escape nearly as easily as if they would have. So we hit play, and these orange particles, as they die, or as they live, they're going to emit other particles, and that's done with the particle emitter from the TP toolkit found right here. You can find the TP toolkit on thinkparticle.com, and what it is it's a utility we've made, a really powerful, great thinking particle starter kit. It's not just for beginners, it's for everyone. And what it allows you to do is create thinking particle setups really, really rapidly. It's a great concepting tool. It helps you get your thoughts out without actually having to focus on the Xpresso. And it's really powerful. And as you create stuff with it, like this, you might find you're actually having a little bit more fun. At least that's been my case. So you have 10 particles a second on each of these, and this first one emits from the initial particle group. Those orange particles will emit a utility particle group. And this blue one lives for 3 frames, and I'll show you how we do that in a second. And as that blue one lives for 3 frames, at the end of the 3 frames, it actually turns into the child particle group, which is the dark, the hot pink one. And then when the hot pink one dies, it's dead. That's where it's dead. It ends there. And then I believe, yes, the child particle group, the hot pink one, will emit other particles in this light blue particle group. And as it emits in that group, you have a third dimension of emission. So let's go ahead and look at this without any, I guess it's not third dimension, but it's the third generation. So you have these orange particles drawing single lines, and some of them will kind of connect visually, but none of them are actually touching. Well, not really a whole lot, at least. And what we can do is we can add these particle groups to emit from particles, and that will give us these angles, like right there, right over there, and that starts to give it some more complexity. And as we add these other particles, you'll start to get a third layer of complexity, and that just becomes very helpful and very useful. So we've emitted these particles. Now they don't have any speed applied to them. All they have is an age applied to them. They have these different directions going out in 45-degree angles, but they're not following that. So how are they moving around, you might ask? Well, if you look in here, we have this p-pass, which will take this particle group and shoot it into our age node. And after 3 frames right here, after 3 frames on this age node, it will go into the particle group of child. So anything from the utility group will go into the particle group of child. So if a particle is living and then it turns into the other particle, it will keep on moving, and when it dies, it dies. Then we shoot it into the set data node, which is just like all of this other stuff over here, which we just explained up here. And I'm going to go over the coffee script real quick. It's in coffee, you have to start with the main function, then you open this up and say, whatever you need to have happen. And if you say if, and then you use your variable, in this case it's called rando, then you can use that as the time controller. And well, it's not really time controller. The rando is a randomly generated number based off of time, hence rando, which is shorter for random. Anything under 3.3 is going to shoot off that speed generated with these with the random node and these math nodes into the x-axis. And then we have a second one that is anything between 3 and 3, and then we use 2 ampersands right there, which says and this code right here. So we use this condition, and you have to use 2 of them, this condition, then we're going to have this result right here where the speed is in the y-axis, and anything above 6.6 is going to go into the z-axis. So that is what we're doing right there, and we have the same thing right here, except for instead of emitting particles up in Xpresso right here, we're just taking particles from the particle, we're taking a particle group from an already emitted particle right here with this tool. So I hope I'm not losing anyone yet. We've got a second group right here that is basically identical, or it is identical to this one right here. What it allows you to do is use, or in this case down here, the only difference is that we used these 2 nodes. They just have different particle groups in them, which is our secondary system right here. So lastly, we have our deflector. If I haven't already explained this, we have the p-pass node, and you shoot it into the deflector, and as it deflects against the deflector geometry, which I explained how I modeled that earlier, it will shoot off an event, and as it dies, it will, or as it hits it, it will trigger the p-die node, and that particle that hit it will die immediately. Now we're using the tracer, and as you use that tracer object, you're going to draw these lines. So I guess we need to slow down and really just kind of explain a little bit more, or I guess review. These particles, the orange ones will shoot out, and as the orange one shoots out, it will shoot out a dark blue one. And I'm going to turn this off right here. Okay, so the orange ones shoot out, and the dark blue ones will come out of the orange ones, and the dark blue ones turn into the hot pink ones. And let's change these colors here so you can just understand them better. Alright, so any particles that come out that are blue are immediately emitted from the initial particle group. Any particle that is purple or pink is or was a blue particle, but it changed after 3 frames. The next particle group will now emit from the pink group, and we have the yellow, which is just the same as the blue. The yellow will shoot out of the pink group, and as it lives for 3 frames, it's going to turn into the green group. And every one of these is supposed to draw these lines. So as you start from the beginning, thinking particles are very timeline specific. So if you're moving around and you hit play and then you go back a little bit and then you scrub forward, you move forward a bit, it's going to affect it. It's got to simulate it. So I usually like to go forward and go to the beginning of the timeline and just use G and F to move around on the timeline a few times. And what that does is it kind of resets everything. And then you can hit play again. And when I hit play, by the way, I use F8. Very handy to use. Okay, so that's what our particles are drawing. And it's based off of this 3D. Actually, this was MoText when I just made it, I believe. And that's the thinking particle system we've used. So anyways, that is the basic idea. If you have any questions or concerns, leave a comment below on the blog at thinkparticle.com or on Vimeo, where you might be watching this. Also, go ahead and email me, sam at thinkparticle.com. If you have any further questions, check out thinkparticle.com to find the TP toolkit. It's a great thinking particle tool for anyone from a beginner to an advanced user. It helps you work a lot faster. And if any of you have any other questions anytime, just like I said, shoot me an email, or you can find me on Twitter at thinkparticle, or excuse me, no, don't use that, at samwelkertv. So that is my shout outs, and Cinema 4D is a great product. I hope you guys enjoyed the tutorial. I hope you keep using Cinema 4D and having fun like I do, and if you have any tutorial requests, go ahead and leave those as well. Thank you very much for watching, and make sure to check out the blog. I'll catch you later. This has been Sam with thinkparticle.com.